Good morning, class. We are looking at college algebra practice test number 4, module 4, chapters 7 and 8. Here's chapter 8, analytic geometry. First, reminding everyone about the pledge when you take the exam. I pledge on my honor that I will neither give nor receive unauthorized assistance and the rest of it, which simply put means, imagine you take the exam on campus. That is my assumption. Okay. In some instances, you may be able to use it, graphing calculator, with some of your exams, including this one. Analytic geometry. Find an equation of the circle with its center at 1, -2 and radius 2. Graph the circle. So what do we know about circles? A circle is the set of points in a plane that are the same distance, called the radius, from a fixed point called the center. So if it's centered at 0, 0 with the radius r, using Pythagorean theorem, gives rise to x squared plus y squared equals r squared. If it's centered at anywhere except the origin, let's say h comma k, then it becomes x minus h quantity squared plus y minus k quantity squared equals r squared. And again, the proof comes from Pythagorean theorem. So x squared plus y squared equals r squared, x minus h squared plus y minus k quantity squared is r squared. We know the area is pi r squared, and we know the circumference is 2 pi r. So what is given? The radius is 2, centered at 1, -2. So we're going to put it into this equation. So that means x minus h, that means x minus 1, quantity squared, y minus k, y minus -2 makes it y plus 2 squared, or 2 squared is 4. So that's it. To graph a circle, one easy way is, of course, to come up with the center. 1 to the right, 2 down. And then from the center, you go r units, happen to be 2. To the left and right, and r units up and down. So if you want to go 2 units to the left and right. So left of this means go to the left, 1 minus 2 becomes -1. So -1, -2. And to the right means 1 plus 2 is 3. So those are the 2 points. Now going up and down. So those are the 2 points. Going up and down by 2 units. So going back to the center, 1 minus 2. Now we're going to go up by 2, down by 2. So if we go up, we add 2, this becomes 0, so 1, 0. If you go down, becomes -4. And those are the points. Very straightforward. Put them all together, that's your graph. So that's how you would draw a circle. So a quick recap. When the circle is centered at 0, 0, the equation x squared plus y squared equals r squared. When it's at a different location like hk, x minus h squared plus y minus k squared equals r squared. To graph it, come up with the center and then go r units, or happen to be 2 in this case. To the left and right, up and down, and put them all together. And that's the graph, and you're done. Number 2, write the equation of a circle in standard form, identify the center, and the radius graph the circle. So that means we have to put it in this format or in this format, obviously. And to do so, we are going to put the x squared and minus 4x together, y squared and 10y together, and negative 7 moves. And it becomes positive 7 on the other side. And what do we do next? Very simple. Completing the square. So that means for this one, when I write it here, and then I'm going to erase it. For this one, b is negative 4 divided by 2 is negative 2. Squared is positive, which means for this one, we're going to add 4 here and, of course, 4 here. For this one, b is 10, half of it is 5, squared, you get 25. And that means we need 25 for this one. We're going to add to both sides. This is x minus 2 squared. This is y plus 5 squared, and 7 and 4 and 25, they add up to 36, which means the center is at 2 comma negative 5. The radius is square root of 36, which is 6. So that's piece of information we should clearly see. I'm going to erase my work. And so we are going to put the center 2 comma negative 5. So 1 and 2 and 5 down here. Now we're going to go R units, 6 units to the left and right, up and down. Okay. So if I want to go from here to the left, that means I'm going to subtract 6 and I get negative 4, negative 5. If I want to go to the right by 6 units, I'm going to add 6 and 2, 8. So I get those. Now go back to the center, up and down by R units. So if I want to go up, negative 5 takes me up by 6, gives me 1. Okay, so that would be 2, 1. If I want to go down, minus 5, minus 6, minus 11. So 2 minus 11, 2, 1. And those are the 2 points. Put them all together. And there you have it. And that's the graph. Okay, I think we are ready to move on. Okay, graph the ellipse by finding its center and vertices. X squared over 25 plus y squared over 16 equals. Let's discuss the ellipse. An ellipse looks like that. So here's the x-intercepts a0 minus a0, y-intercept 0b, 0 minus b. Here's focus 1, focus 2, foci. And here's the definition. An ellipse is a set of points in a plane the sum of whose distances from two fixed points is a constant. So any point, for example, P, from the two fixed points. The two fixed points are called foci, each is a focus of the ellipse, F1 and F2. Represent the two foci of an ellipse. So PF1 plus PF2 is fixed, and it is equal to 2a. So it's very straightforward. That is the definition. And if it's centered at 0, 0 has the equation x squared over a squared plus y squared over b squared equals 1. If it's centered at somewhere else, for example, h and k, x minus h squared over a squared plus y minus k quantity squared over b squared equals. Now, a couple of things. The area is pi a times b. Please understand that circle is a special case. Circle is a special case of an ellipse where a is equal to b and we call it r. Okay, and so we know the area of a circle is pi r squared. That's why we get pi ab. It's really pi ab. In the case of a circle, a and b are identical. We call them the radius. And the relationship between a and b, this distance is a. That's why it's called a0. This distance is b. That's why it's called 0b. And they follow Pythagorean theorem, where b squared plus a squared, b squared plus c squared, this one. Connect these two. B squared plus c squared equals this, and this is equal to a. And the reason is actually fairly simple if you draw this one, because the sum of these two, if you put the p here, pf1 and pf2 is fixed, and it's equal to 2a, so each one must be a. So if I draw, this one, and I put the p here, then by symmetry, this distance and distance are the same, so this distance becomes half of that, which is so b squared plus c squared equals a squared. It follows Pythagorean theorem. Let me erase and continue with that. So compare to this one, and you notice a squared is 25, so a is 5. B squared is 16, so B is 4, centered at 0, 0. So to graph this, we start from the center and we go a units to the right and left. So here's the center. A units to the right and left. Those are called vertices. What are the vertices? If the ellipse is elongated along the x-axis, then and it's centered at 0, 0. The vertices are a0 and negative a0. A0 and sometimes it's elongated, that means longer along the y-axis, then 0, B, and 0, negative B. Those are the location of the vertices, okay? So wherever it's elongated. Now, you go back to the center, B units up and down, those are called co-vertices. 0, negative 4, 0, 4. And now you put them together. And that's a graph. Again, if it's elongated this way, those are the vertices, and those are co-vertices. If it's elongated along the y-axis, they become the vertices, okay? Again, reminding you of the formulas given to you. Identify the coordinates of the center, the vertices, the co-vertices, and foci, graph the ellipse. So clearly, we're going to compare it to the standard form, this one. So when we compare 4a squared, so a is 2, b squared is 9, b is 3, it's centered at negative 5, positive 7. So it's a matter of comparison. Now, one thing I want to tell you, I keep a squared under x, or x minus h quantity squared also. So that will keep the formula intact as far as the uh, an ellipse is concerned. And later on, we discuss the hyperbola as well. To me, it's important to keep it that way. Now, please understand, Pythagorean theorem is the way it works. The larger one is the hypotenuse. And if it's elongated along the x-axis, a is the larger one, so b squared plus c squared equals a squared. However, in this case, b is larger than a. Therefore, they interchange. So a squared plus c squared, okay? So that's important to understand first and foremost. In any event, so we are going to put this center negative 5, 7. So we come 5 units to the left, and we go up by 7, and we end up somewhere there or close. Now we go A units to the right and left, B units up and down. That doesn't change, okay? So if we want to go with the vertices first, because this is larger, we're going to go B units up and down. So this 7 changes to 10, or 4, minus 5, go up, minus 5, 10, go down by 3 units, minus 5, 4. So those are the points. A units left and right. So left minus 5 becomes minus 7, right minus 5 plus 2 becomes minus 3. So A units left and right. Now, put them all together. That's the graph. So Identify the coordinates of the center, the vertices. So again, it's important to know it's elongated along the y-axis. Therefore, those are the vertices, not these two, okay? And the co-vertices, now we want to find the foci. Now, it's important to understand it's one of these two. Because B is larger, we're going to go with A squared plus C squared equals B squared. A squared plus C squared equals B squared. A is 2 squared. C, we have no idea. And B is 3. This is 9. This is 4. So C squared is 5. C becomes square root of 5. So because the vertices are along the y-axis in essence, so from the center goes C units up and C units down. Those are the foci. So you go back to the center, minus 5, 7, and you're going to add this number and subtract. First, you subtract, you get about 4.77. Then you add, you get about 9.24. And those are the foci. That's extremely important to understand, everybody. Now, use the graph of the ellipse to determine its equation in standard form. Before even we move on, you recognize that it's elongated along the y-axis, right? So you throw in some points, and we are going to use this formula, obviously. So let's see what happens. In a matter of comparison, we notice the center is located at -2, 2. And those are the 4 points. The vertices are located at -2, 5, -2, -1. Co-vertices are located at 0, 2, -4, 2. So we locate those points. This is the distance for B. This is the distance for A. And as you can see, this distance, all you have to do, they have the same x coordinates, 5 minus 2. So this distance is 3. And this one, between -2 and -4, the distance of 2. So 2 units here, 2 units here, 3 units here. So we have x minus h, x minus minus 2, that means x plus 2. Quantity squared over a squared over 2 squared, which is 4. Y minus k, y minus 2 quantity squared over b squared over 3 squared over 9 equals 1. So a is 2, b is 3, and there you have it. So we can read from the graph and handle it easily. We are going to move on, everybody. So that's as far as ellipses are concerned. Now give the equation of the asymptotes and graph the hyperbolas. The first one, A, x squared over 16 minus y squared over 25 equals 1. The second one is y squared over 25 minus x squared over 16 equals 1. What I want you to notice that this one, the coefficient of x squared is 1 over 16, which is positive. In this case, the coefficient of y squared, which is 1 over 25, is positive. So what is the difference between the two? We are going to discuss that in a moment. Here's the general shape of a graph of a hyperbola. Here's the asymptotes. X squared over a squared minus y squared over b squared equals 1, or y squared over b squared minus x squared over a squared equals 1. What I want to make a point of, I keep the a squared in both cases under x. When I do that, the equation of asymptote doesn't change. If you don't, it will, and most texts actually do that. I like to keep the equation of the asymptotes as plus minus b over a times x. And in this case, in the case of hyperbolas, always a squared plus b squared equals c squared. So this distance is a, see a0. This distance is b, 0b. And the distance from here to the focus, focus 1, focus, this distance is c. A squared plus b squared equals c squared. So no matter how you draw that, c is the largest one. So what is the difference between these two? If you have it in this format and the coefficient of x squared, as it is the case here, positive, then it opens sideways to the right and to the left. If it's the other way around, the coefficient of y squared is positive, everything looks the same, but it opens up and down. That's the difference. So here's the definition: hyperbola. A hyperbola is the set of points in a plane, the difference of whose distances from two fixed points called the foci is a constant. Pf1 minus Pf2 equals 2a. So if you pick a point anywhere and connect it to the two foci, f1 and f2, of course, clearly this is larger. So Pf1 minus Pf2 is 2a. Sometimes they just write the absolute value of that because it depends how you choose your foci and which one becomes larger. But the distance, if this is larger, the distance is 2 times a. And it's actually, please understand, this distance is a, everybody, in this graph at least. This is a. Okay. So if you pick the p to be here, the distance from here to here minus the distance from here to here becomes this, which is 2a. That's easy to prove in any event. So what happens in both cases, centered at 0, 0. A equals 4, B equals 4. So whether we go with this or that makes no difference. This part is identical. Again, the way I'm going to keep it, that a squared will be under x squared, that works that way. And in that case, y is plus minus b over a, 5 over 4. x. So that's the center for both cases. And the asymptotes, plus minus 5 over 4 times x. Now, we're going to look at the blue one. So everything is the same, the center A, B asymptotes. So you graph the two lines. Basically, uh, you graph, let x be 0, find y becomes 0, 0. And then if x is, for example, 4, y becomes 5 or negative. Now, and I'm going to discuss this one, which is known as a fundamental rectangle. So if we go with this one, the vertices are along the x-axis and they open sideways. So for this one, the vertices are at 4, 0, minus 4, 0. So for this one, 4, 0, minus 4, 0, and then you graph it. And you're done. The first part is done. For part B, everybody, the vertices are up and down. Okay, so you, because the coefficient of y squared is positive, so it's at 0, 5 and 0, negative 5. So up and down by 5 units. And those are the graphs. Now, this is the same, asymptotes are the same. And if you look at this one, this is called a fundamental rectangles. Fundamental rectangles, you can graph that to help you draw. If you draw the diagonal, they would be the asymptotes. Now, of course, this may not be to scale, but the idea is as follows. So this is the fundamental rectangle, okay? Which is the same for the bottom one. And the idea is that, let me just put the corners. So you have this corner. Four, 5. I have this corner. 4, negative 5. I have this corner. Negative 4. Positive 5. Actually, this one doesn't look. Negative 4, positive, negative, negative. So I'm going to go back to A and B. So put 4 and 5 together, both of them positive, both of them negative, one of them negative. It creates the 4 points. So right here, in order to draw this, just put 4 and 5 together and then change them into various signs. Draw the diagonals, and those are the asymptotes. Okay, that's how you arrive at those. So that's the way to draw it. Identify the coordinates of the center, the vertices, foci, and the equation of the asymptote. Graph the hyperbola. X minus 1 squared over 9 minus y minus 2 quantity squared over 16 equals 1. And again, those are the equations. What I want to add is that if the center is no longer at 0, 0, then just like the circle, just like the ellipse, you write x minus h quantity squared over a squared, but this time minus y minus k quantity squared over b squared, or maybe y minus k quantity squared over b squared minus x minus h quantity squared over a squared. So the result is the asymptotes that there were plus minus b times or b over a times x. Now, just the way it works, remember, we had y equals plus minus b over a times x, right? As the asymptotes. Now, if you go with this one, the x changes to x minus h. You go with this one, y changes to y minus k. That's exactly how you get this one. Anyways, so let's go back to this one, and we clearly recognize the center at 1, 2. A is square root of 9 or 3, B is square root of 16 or 4. So in other words, this one. So the center is at 1, 2, 1, 2. So that's where the center is. So that means the asymptotes go through that. The coefficients for x are positive, okay? So that means after you have that, it opens sideways. So from the center, we're going to go a units to the right and left, where a is 3, everybody. But in any event, let's come up with the asymptotes y minus k. That means y minus 2. Okay, so these are the asymptotes. Y minus k, that means y minus 2, plus minus b over a, 4/3. X minus h means x minus 1. We move the negative 2, we get plus 2. So if you go with the positive, and we're going to do both of them. So I'm going to do there. This is 2 equations. So let's do both. So if we go with the positive, we get 4/3 x minus 4/3 plus 2. And 2 is 6/3, so we get plus 2/3. And so to graph this, obviously, this is the y-intercept, 0, 2/3. And then if you set this one equal to 0, drop the denominator, 4x plus 2 is 0, negative 1/2, 0. I'm assuming everybody can do that. So x is 0, find y is 0, find x. So this one is just given, and this one you can see that if you set this equal to 0, you get this one. All right. So you can graph that 0, 2/3, negative 1/2, 0. It's not perfect, but it's close if you look at those intercepts. Now let's go with the minus. So I'm going to write here y equals minus 4/3 x minus 1 plus 2, which makes it minus 4/3 x plus 4/3 plus 2. And these two add up to 10/3. And now 0, 10/3, of course. I'm assuming nobody has any problem with the intercept. If I put 0, I get 10/3. And if I set this one equal to 0, minus 4x becomes 10, or 4x becomes 10, 10 over 4, or 5 halves. So I hope everybody is okay with finding intercepts. And the graph of okay, 0, 10/3, that means 3 and 1/3, a little bit above 3 and 5 halves, 2.5. So those are the ones. And all you have to do after you find the intercepts, find the vertices. To find the vertices, because it opens sideways, and the reason it opens sideways because the coefficient of this guy is positive, you go a units from the center to the right and left. All right, so we are going to go a units to the right and left. Let me erase my work. So if I want to go to the right, 1 and 3 becomes 4. So 4, 2. If I want to go to the left, 1 minus 3, negative 2, 2. Those are the 2 points. And all you have to do, just draw graph. So you're done with the graph. We are going to, so those are the vertices, okay. A, B, center, asymptotes. So what is left? Foci. Now, in the case of a hyperbola, a squared plus b squared is always equal to c squared. So that doesn't change because c is always uh, larger than the 12. So because it's elongated, it's along the x-axis, then the foci, everybody, is somewhere here and somewhere here. Are you with me? So it's to the right of the center and to the left of the center. Okay. And it has the same y coordinate as the center. So we know the y coordinate is 2. But what is the x coordinates? We are going to go c units to the right. So let's find the c. A squared plus b squared equals c squared. So 3 squared plus 4 squared, that means 9, 16 is 25. So it makes c equals 5. The center, this capital C is the center, everybody. This lowercase c is the distance from the foci. So we're going to start from here, and we're going to go 5 units to the right. That means become 6, 2. 5 units to the left. So from here, 5 to the right, 5 to the left. When you go to the left, 1 minus 5, minus 4, comma 2. And those are the points. Let me erase my work. So a quick recap. From here, we can find the center A and B. We can calculate the asymptotes. Give us these 2 equations, and we draw the 2 lines. By the way, the asymptotes must go through the center. Then, because the coefficient of x is positive, so we are going to go a units to the right and left to find the vertices. and then we do the drawing. Then back to the center, C units to the right and left to find the foci, and to find the foci, A squared plus B squared equals C squared. We are going to move on, everybody. Use the graph of the hyperbola to determine its equation in standard form. Couple of things you want to notice, that the hyperbola opens up and down. So ultimately it follows this format. Where's the center? Negative 1, 0. We want to find A and B. So where are the vertices? So this is the center. The vertices are located at negative 1, 3, negative 1, negative 3, which means B units up and down. So what is this distance? From 3 to 0, 3 units, or from 0 to negative 3. So the distance is 3 units. B equals 3. This distance, B equals 3. The foci is C units up and down from the center. So the center, negative 1, 0, foci, negative 1, 3 square root of 2, clearly the distance of 3 square root of 2, right? So those are the foci, negative 1, 3 square root of 2, negative 1, negative 3 square root of 2, and therefore C must be 3 square root of 2, this distance. A squared plus B squared equals C squared. We have the B, we have the C, we plug in. When we square this one, we get 9. This one we get 9, this one we get 2, the product is 18. I hope you know how to do this, everybody. 3 squared of 2, 3 squared and squared of 2 squared, and multiply. This becomes 9 times 2, 18. So that means this is 9 and A becomes 3. So we can write the equation. We replace, so we are following that. We replace everything here. So y minus k, k0. This is, everybody, this is h and k. So y squared over b squared 9. X minus h, x minus negative 1, x plus 1 squared over a squared. That is also 9. So we got that. We're going to write this y minus k, that means y, equals plus minus b over a, b over a, 3 over 3 times x plus 1. So this is y, this is 1. So plus minus x plus 1, and you can graph it. And that's the final answer.